You are all cordially welcome. I'll be using the name Dr. KOA, but that is my name on the screen there. I'm a doctor and a professor in Legon. I'm also a visiting professor in Warwick University in the UK and a visiting professor in Stellenbosch University in South Africa. My area of specialization is efficiency and productivity studies. Okay, efficiency and productivity analysis using data envelopment analysis and stochastic frontier analysis. I'll be walking you through this course in operations research, but the business name is management science. Along the line, I'll be showing you areas you can one day get a research topic from for your PhD and even for your academic and thesis and journal paper writing. All the information you will need for this course, some of them are on my personal website that are here, some of them are on Sakai website that are there. Always keep in mind the following. Always keep in mind the following. Torture numbers and they will confess to anything. This is from Greg Easterbrooks. Torture numbers and they will confess to anything. That's what we are going to be doing. My approach to this work is not to... All right, just a second. So, let's start. All of you are welcome to the journey through the valley of the shadows of management science. Every single person is welcome. And like I've already indicated, everything is on the Sakai that you get. I've given you the lecture slides already. You can Google my name on the Google and then it will take you to my website and you can get past lecture slides for this. Please turn off your phone if possible. If not possible, don't put it on vibration. Rather, silence it completely. It's going to help you to cogitate. It's going to help you to understand what we are doing. Because you need a mind, a different cerebral cortex to be able to understand what we're about to do. Use the Sakai a lot. Use the Zoom links a lot. They are all on the pages and they are all on the Sakai. Email me if you early on find that you got problems, okay? And remember that the course needs lots of thinking, but it requires that you sit down. But it's very doable. It's very doable, okay? It's very mathematical, but I'll make it more practical than mathematical. Very, very practical. You see that. These are the lecture days that you have, okay? And if you happen to observe all COVID-19 protocols, you can come to the office and then by appointment, and then if you don't understand anything, I can walk you through that. This is the exam structure, and this exam structure is a structure designed by the university. 70% of everything will go into class assessments. Personal problems, independent works, you know, where there is evidence of popping, students will be punished with a 0 score. Class participation is part of the 70%. Presentation is part of the 70%. Group work is part of studies in groups of 4 or 5. This is when I think so. When I don't think so, it will be an individual thing. So there will be class tests, there will be class assignments, there will be group works, and then there will be presentations. The final exam, where you will do an exam, you know, like an online exam, but then you are given a certain hours or days to complete it. This will be 30%. This is under the COVID-19 protocols. My teaching style is very interactive, so I will be asking you a lot of questions. Once you raise your hand, I'll call you. And once I call you, you can now submit your answer. And I will record all of this as part of your continuous assessment. Okay, so let's start. What is management science? Another name is operations research or operational research. Mostly if you're in the UK. If you're in the US, it's mostly operations research. Operations research, which is the way I tend to sometimes look at it, is a scientific approach to decision making. And we try to determine how best to design and operate a system under conditions of scarcity. Now, in the world of business and in economics and other areas, it's been termed as a management science. And in that context, it's the same quantitative method that will be using a lot of mathematical models, algorithms, which are procedural analysis, okay, and also adopting computational technology to deal with real life situations. Okay, so you'll be dealing with real life situations. And I'll be giving you some of the real life situations even now for you to even appreciate it better. Okay. Now, the word algorithms in operations research is an important terminology. Okay, because the algorithms are like tools for effective systematic problem solving and decision making. I'll give you an example. How can a manager decide well in advance and in the presence of scarcity and uncertainties what to produce and charge? How can you do that? What to produce and charge? How can you assign, schedule, task, and manage the resources? How can you banks reduce queues? If you look at the queues that build up in banks, how can they reduce the queues? There are models for dealing with that, such as queuing models. This normal daily decisions, okay, you can use management science to deal with them. Now, let me give you a bit of a history of management science, not so long. Okay, it started in the Second World War around the 40s by the British and US military, and the scientists were tasked to develop strategies for dealing with the war. You know, in war, there's a lot of strategy. Okay, sometimes the first combatant move first, the second combatant move second. There is a network and there is a strategy. And so scientists were challenged to develop strategic approaches for tackling the war. And those tools today have now been applied in the world of operational research. And today it is sometimes in the world of management science or decision science. All of these terminologies are used interchangeably, but then they come out from the strategic models developed. And after the war, now we have a lot of applications in engineering, in transport, in health, business, marketing, finance, telecommunications, services. All of these areas you can now apply management science. So guys, when a person is doing management science, that person is broadening his horizon in several other areas of the business disciplines and even non-business disciplines. So you will notice that in some departments, management science is studied, or operations research is studied in mathematics department. Sometimes it's studied in economics departments. Sometimes it's studied in statistics department. And it's studied, of course, in the business schools. So it's very, very, applicable in many areas. These are some of the techniques that we'll be studying in this course. Okay. Not all of them, but some of them. Mathematical programming, it will be the bedrock. It is more or less the cornerstone of management science. And there we'll be looking at duality, sensitivity, transportation, assignment models. Okay. Dynamic, integer, linear, nonlinear, goal, stochastic programming, semi-definite, semi-infinite, conic programming, robust optimization. All of these are under mathematical programming. Then beyond that, look at deterministic inventory models, forecasting, queuing models, network, decision analysis, game theory, simulation, Markov chain, project management, probabilistic models. All of these, don't be worried, I'm just trying to be, quite enjoying myself. Okay, all of this are studied under the area, but of course we can't do all of them, so we'll be quite selective in this. I'll give you a typical overview of some of these. For example, linear programming will maximize or minimize a linear function subject to some constraints with a goal that you are going to get some profit or revenue or higher sales or membership. The queuing model that I spoke about, the essence of that is to help managers understand and make better decisions when it comes to operations of systems involving waiting line. In areas where people have to wait, like students queuing to get registered, like customers queuing to get served in a bank, like motorists queuing at the toll booth in order to get entry on the main road. All of these are queuing analysis, and we use queuing that to do that. Data envelopment analysis, or DEA, is a linear programming approach for assessing the relative efficiency of decision-making units, which are homogeneous in character, and they use a lot of inputs to produce a lot of output. This you will study in your second semester fully as a course. So you'll be doing that. Let's look at real-life applications of management science, which have made a lot of people save a lot of money. A lot of money. For example, the American Airlines use forecasting, and we shall do forecasting, and optimization, which we shall do, to offer discounts and full fares when it comes to revenue management. Okay? And they did that, and they were able to make $1 billion incremental revenue every year. So that tells you that this course is very applied. Okay? China optimally selected and scheduled massive projects. When it comes to projects in China, people know about it. Okay? In 1995, they were able to meet the country's future energy needs using what? Optimization and scheduling. And they were able to save $427 million using the course that you are about to do. So you have a consultancy deals if you pay attention to this. South Africa Defense Forces, they were able to use optimization to redesign the size of the shape of the defense force, the entire defense force, the weaponry systems. In 1997, they were able to use optimization, which we shall study. And they were able to save $1.1 billion. What you're about to learn is a very, very big thing. A certain bank, which I know, okay, in California, okay, used data envelopment analysis to improve the productivity of the branch and the profit. The bank was able to identify $6 million, okay, of expenditure, annual expense savings, which couldn't have been identified with the traditional financial ratios. Okay. And so that tells you that data envelopment analysis, which depends on linear programming, is very, very applied. So these are a few award-winning situations, but let me give you very practical, home-based, very, very interesting one that every child will agree. If you are to schedule a holiday in London or in LA, normally some people will use something we call Sky Scanner. A Sky Scanner will try to search and give you the cheapest fare. Now, the algorithm developed by the operations researchers will search among millions of options to find the cheapest fare for you. Now, once you've been able to use that algorithm, this is operations researcher. Another algorithm, another procedural analysis will schedule the flights, crews, and aircraft used by the airline. And then if you happen to get to London, okay, if you rent a car, the price you pay by that cab, the black cab, is determined by a mathematical model that will seek to maximize the revenue for the car rental company. So we are talking about serious application of management science. And this is very, very important. So it's important you have to understand that the course you are doing is not just for research. Oh, there are loads of research in this, but it is practical. And there are loads of business applications to it, loads of them. So whilst you are going to learn a lot of mathematical, innuendos, don't worry, this is very applicable. Okay? But because you guys are research people, I'm going to let you also understand the theoretical underpinnings of this. Now we'll be using models. So the question becomes, why do we use too many models? Well, models will help us to deal with real-life situations. Okay. For example, if I give you an aeroplane, okay, a full-sized aeroplane, and I tell you to look at it and build it, it's going to be difficult to do. But if I tell you to build a small aeroplane, that will be quicker And you can use that as a simulation to be able to know how the bigger aeroplane will behave. So models are just representations of reality. Take note. A model is a representation of reality. And that representation, you can manipulate it better than if you were to manipulate a normal real-life situation. So models will help managers to detect profit without producing and selling the unit. For example, you'll be able to know, and you see that in this course, that, oh, this is the profit I'm going to make. Even before you start producing, you will know your profit. It can help you to reduce the risks associated with operations. But the beauty is that if what you're going to do is going to be naturally good, then it would depend on how well it represents the real world. You see, the real world is not easy to represent. There are behavioral characteristics on certain actions which may not be captured in the model. So the beauty of the model is contingent on how well the real life is. So let's look at the first topic of management science, and that is linear programming. Linear programming. Okay. We sometimes shorten it as LP. LP. The idea of linear programming is to solve a variety of problems related to management, scheduling, media selection, financial planning, capital budgeting, transportation, and all of that. Okay. That is how it is related to. And like I've indicated, if you have any question at any point, just let me know. So let me give you a brief history of linear programming, just one slide. It was made up of linear relationship. So that's why the word linear comes in. A line. A linear relationship among decisions given an objective and constraints. The whole idea of linear programming was first postulated and applied to problems in economics in 1939 by Kantorovich. It was hidden from 1939 until first conceived by Danzig around 1947, and this was after the war. Okay, so that should give you an understanding of why we said it came from. Now, Kantorovich and Koopmans, they shared the 1975 Nobel Prize in economics for their contribution to the theory of optimum allocation of resources. Okay. So Koopmans is another guy who coined the term linear programming, and you hear of him when we come to the world of data element analysis. But it was Danzig who published the simplex method in 1949. Now the simplex method, you will learn it. You will learn it in study 3, where is the algorithm for solving linear programming problems. Okay. That is a procedure. It's called simplex method, and you will learn it in this course, so don't worry. So we are going to do a bit of linear programming. Okay. So you will need your pen and paper to be following me as I share some. The components of linear programming are the following: decision variables. Decision variables. The items you want to decide on. For example, how many bags of rice do you want to produce? That is a decision variable. You got to decide. How many bags of rice? How many quantities of cars do you want to produce? How many gallons of oil or barrels of oil do you want to produce or sell? That is the decision variable. Then the parameters in question will be whether you want to minimize the cost or you want to maximize the profit or revenue. And of course, there's always an objective, which has to be either maximized or minimized. So the cost will have to be a cost minimizing objective. And then we can have a revenue maximizing objective. And then of course there are constraints. There are constraints. There are restrictions, limitations. For example, one of the things that limit us is time. We all have 24 hours a day, but we don't use all of them a day. Okay. 8 hours a day. So we are time constrained and also labor constrained, because sometimes you can't employ everybody. The law of diminishing marginal utility will set in. So you can't let 100 people work on one flower pot. It will not make sense. And then sometimes certain materials, for example, if you are baking bread, the flour, okay, these materials, and then money, all of these are constraints. And you've got to incorporate these constraints into your discussion. We are going to explain linear programming right now, right here, using a very simple example that all of you know about. But before that, let me give you the properties of linear programming. Okay. I will encourage you to read the book by Winston. If you go online, you will see the course outline. Winston book is there. If you want it, ask Isa to give it to you, and then you can get it also in the library. Pages 53 to 54, you will get these properties of linear programming. The number one property is that you need one objective function. You don't need multiple objective functions, okay, such as Go programming. You need one or more constraints. And then you need alternative courses of action. There is a property of proportionality and additivity, divisibility, and certainty. Like I indicated, when you read more of this, you will appreciate the properties. So I'm going to take a simple example and work through it with you. This is where your pen and paper has to be ready. I'll be using a board right now to show you how the thing has to go. This is a preamble, and I want you to get a preamble. Yes, Stephen, your hand is up. Let me unmute you. And then you can ask your question.
Hello, Doc. Sir, please, you mentioned the book in the previous slide. I missed that.
The name of the book?
Okay, Doc, please, you mentioned... Yes, please.
Okay, the name of the book is Winston. The author is Winston, 2004, okay, Operations Research. It's in the course outline. So when you go to the Sakai online, you will see this on the course outline. Okay. And in fact, if you want a book, Isa will give it to you. All right. Okay. Now let's go on. So I want somebody whose system is very good to read, who can read the storyline for us. Okay, raise your hand and let me see. So I want somebody to read so that I will not be the only one talking here. Okay, who is ready to read for us? Raise your hand and let me see who can read for us. Who is bold enough and has had lunch? Okay. Steven, I think you are ready to go. You do the reading for us. Steven, I think your network was a little bit rough. Yeah, your network was a bit rough. Who else wants to try? Who else wants to try? Class rep, are you around? Okay, Eunice. Eunice, let me unmute you.
Same.
Okay, go ahead.
Farm Milk Ghana Limited produces Fan Yogo and Fan Choco. Some Ghanaians love these. I don't know about you. The two key resources used by the company are milk and skilled labor. Given the limited resources, the company desires to know how many sachets of Fan Yogo and Fan Choco to produce each day in order to maximize profit. There are 40 hours of labor and 120 gallons of milk available each day for production.
Continue.
Fan Yogo requires 1 hour of labor time and Fan Choco requires 2 hours. Also, Fan Yogo requires 4 gallons of milk, whilst Fan Choco requires 3 gallons. The profit from a sachet of fine yogo is 40 Ghana cedi per unit, and from fine choco is 50 Ghana cedis per unit. Formulate a linear programming model for this product mix problem and solve using graphical analysis.
Very good, very good, very good, very good, very good. So let's look at the steps in undertaking this. The steps in undertaking this, and the most important step is formulating the linear programming model. Now, before you will be able to formulate the model, you need to understand some few things. You need to understand the characteristics of the model. And I'm always going to challenge you guys to know one specific criteria characteristic. So I want to show you something on the board. Okay, so just watch me whilst I show you something on this board. I'm sure you guys can see the board. Okay, so always there are some key important things you want to note. And number one, okay, the steps you want to follow to be able to do this. The first thing that you want to identify and be able to use to appreciate, first organize yourself well, is to know the decision variables. You want to know the decision variables, okay, that are being spoken about. You also want to identify the objective. The objective. And then you also want to identify certain symbols that are needed. Symbols, because certain symbols that are needed to be able to do that. Then you want to understand the constraints. Okay, constraints. That are needed here. And under the constraint, let me change the color here. Under the constraint, there are certain things that you will have to take notes when it comes to the constraint. And this the fact that is the fact that the constraint, you need to know which ones are they used, followed by the signs, and followed by the available. And I'll go through all of this. Okay, so these are very important points that you want to be able to take note. I hope that you've been able to write them. Okay, I hope you've been able to write them there. So let's pick them one by one by going to the preamble. Okay, let's go to the preamble. And I'm sure you can see the preamble now on the screen. Now, when you look at the storyline here carefully, you can raise your hand and answer me. What do you think are the things we need to decide on, the decision variables? Sometimes you can see it in the story beginning, sometimes you can see it in the story ending. What are the decision variables? You can raise your hand and tell me. Eunice, is your hand up? Variables. Unless you probably didn't lower your hand from the previous. So you can click lower and lower your hand if you didn't raise your hand up. Other than that, tell us. Who can tell us the decision? What are we deciding on? What are the items that had to be decided? The decision variables. Who can tell us? Yeah. Okay, Kobna, Janet. Okay. Janet. Let me see. Yeah, Janet, you can go ahead. Kurubini. Yes, Janet, go ahead.
I think the decision variables would be the number and the trading.
Sorry, your voice was a bit far.
I think the decision variables would be the milk and the skilled labor.
Okay, but that's not the decision variables. Those are the things. Those are not the things we want to decide. And let me go to Kurubuni and then you justify why you said that. Okay. Kurubuni. Oops.
Yeah. Hello, sir.
Right.
Hello, can you hear me?
Yes.
I think the decision variable here.
Oh, sorry. Start again. Kurubuni, you can now unmute yourself. I've given everybody now the chance to mute and unmute yourself. So you unmute yourself and go ahead. Kurubuni, you can click on mute and then do it. Oh, or not. Yes, you can do that. All right, Stephen.
All right, Doc. I think the decision variable is how many sachets of fine yogo and fine chocolate to produce each day.
Very good. Very good. So the key point is the fine yogo and then the fine chocolate. That's the key point. Fine yogo and fine chocolate. But of course, these have units of measurement. Okay? They have units of measurement. And that is why it is important to give the units of measurement for it. So when we go back here into our analysis, the decision variables are fine yogo and fine chocolate, but then they are in certain units of measurement. And so you always call them with their units of measurement. And what is the units of measurement for fine yogo here? You can tell us. What was the units of measurement? You can type it in the chat room or you can raise your hand. Yes, units. Unmute yourself. What?
In sachets, please.
Again.
The number of sachets.
Exactly. Number of sachets of fine yogo. Number of sachets of fine chocolate. Now, once you identify the number of the decision units, the decision variables, once you identify that, what you then do is that you will represent them with a symbol. And the symbol we always use is x1 for the first decision variable. All right. X1 for the first decision variable. And then x2. What is this thing? X1 for the first decision variable, and then x2 for the second decision variable. And so you have to write it. The x1 is the number, don't write it the way I'm doing it, okay? The number of sachets of fine yogo, okay? So you want the representation. The number of sachets of fine yogo to produce. So now you've written the decision variable. And you know that there are two of them. Now you have fine chocolate. So the same thing. The number of sachets. Sachets is a unit of measurement of fine chocolate to produce. Okay. Once you've written this is a very, very great max to achieve, to be able to begin understanding this decision variable. Once you've understood the decision variable, you now need to write your objective function. You need to use that principle to write your objective function. Now let's go back to the storyline and I'll share something with you. So when you go to the storyline, there is something that is in the story that will help you to know that the decision variables are always per unit. Per unit. So always look out for that. So the next thing we are talking about here is the objective function. And let me just give you an idea about how you should always focus the objective function. How you should always forecast the objective function, because you need to have an idea of how to forecast the objective function. The objective function should always, and it is always represented by Z. Okay. There's something written at the subscript, and I'll come to that. And it should be made up of the units in which the thing was measured multiplied by that decision variable, plus the units in which that thing, the per unit price, okay, multiplied by that very, this is supposed to be 1, okay, multiplied by that unit, plus the actual price attached to it, multiplied by that unit, all the way, okay, up to, C, P, and then X, P. Okay. So as many as of the S's that are there, you try as much as possible to deal with them. Okay, let me just write this X well. And so you need to know the price, that's a per unit price for each of the sachets of yogurt or chocolate that is going to be produced, the per unit price, multiply it by the quantity. So the price times the quantity, the price times the quantity, the price times the quantity, because you are trying to formulate an objective. Now, if it is cost, again, it will be price times quantity, which is cost. Now, if you can remember your economics, okay, we defined total revenue as price times quantity. Okay, total revenue as price times quantity in a competitive environment. Okay, it's the same principle here. And of course, total cost is also given as price times quantity. Okay, and then you can do that for each particular, each particular decision variable, and then add all of them. And that is the same principle that is here. Now you have to determine whether you are doing a maximization or a minimization, and of what. So you are either going to maximize or you are going to minimize. But what? What are you maximizing or minimizing? You are either maximizing or minimizing profits, revenue, or minimizing costs. Okay. Sometimes audience. Okay. Sometimes exposure. So you will have to identify exactly what you are maximizing or minimizing. Now you got to go back to the storyline. Let's go back to the storyline and tell me whether you are maximizing here or you are minimizing, and what guided you. Who can tell me? Are we maximizing or we are minimizing, and what guided you? Who can tell us? Maximizing or minimizing? Any idea? Any idea? Any idea? Okay. Maximizing or minimizing? Yes. Eunice. Maximizing or minimizing?
We are to maximize profit.
Okay. So you found that in the story, and that will guide you. Now, please note that it's not all the time that you will see the word maximize, to give you a clue. Sometimes the story package should give you a clue that, oh yeah, obviously you're going to maximize these things. Okay. Obviously, we're talking about something like pollution. If you hear the word pollution, are we going to maximize or minimize? Are we going to maximize or minimize? Anybody? Okay, otherwise I'm going to do some quick. Yes, Mark, are we maximizing?
In terms of pollution, we will be minimizing.
Okay, Mark, stay there. Okay. Well, how about if you are talking about spectators in a hotel, in a stadium? Spectators in a stadium, are we maximizing or minimizing?
For spectators in a stadium, it will depend on the situation. If
you like to depend on a normal situation.
Okay, normal situation, we would like to maximize it.
Exactly. We like to maximize. Okay. What about audience in a theater? Mark, still on you. What about
Audience in a theater, also, you would like to maximize it because the more tickets you sell, the more profit you make.
Good. How about vaccine to vaccinate people? Vaccine to vaccinate people.
Yes, we would like to maximize also that one because
Okay.
the more
How
people
about
you
distance?
maximize,
Thank you. How about distance to travel to a place?
actually, you would like to minimize the distance that you travel to a place
Good.
so that you can get there.
How about a pandemic in a particular place?
You like to minimize that also.
Exactly. So you see, even without using the word, thank you. Even without using the word maximize and minimize, you are able to tell clearly that this is a maximization or a minimization. It is an understanding that leads to the outcome. It's understanding that eventually leads to the outcome. Okay, so with that in mind, we go back to our model that we are trying to formulate, and you will have to now choose at the bottom here. You have to write max there, okay, to indicate maximize. Okay. Now let me clear this and rewrite the whole thing. So now we have to identify the content of what we are going to do. So we are going to now write our objective function as z and then attach max to indicate maximize equal to x1, and x1 is representing fan yogo. So go to the storyline. Let's go to the storyline and then look out for c1 for x1. c1 is a per unit. Remember, here is profit, so it's going to be per unit profit for fan yogo. Per unit profit for fan yogo. So what was a per unit profit for fan yogo? Sometimes you have to read a star story. What was a per unit profit for fan yogo and for fan choco? Anybody? What was a per unit profit for fan yogo and for fan choco? Who is ready to rock and roll with that? What was a per unit profit? Kurubini, Kajitan, unmute yourself and answer.
The per unit profit for fan yogo is 40 cedis, 40 Ghana cedis. And that of fan choco is 50 Ghana cedis.
What will I do with this? What do you think I will do with this? According to the formula, what will I do with these? If I get them, what will I do? Let's go back. Okay, I'm about to write them here. What do you think I will do with them? You said this one is for fan yogo was represented by x1, and you said per unit profit was 40. Okay, and you said fan choco was, represented by x2, and the per unit profit was 50. What am I going to do with them? With these two? I have to add them. Yeah, I have to add them because to get a profit, I must know the per unit profit. Okay, so let's assume that the number of sachet, remember x1 is representing the number of sachet of yogo, and x2 is the number of sachet of choco. All right, now I know that the per unit profit, the profit I will get for one yogo is 40. And the profit I will get for one choco is 50. And so, if I want to know the total profit I will get for yogo, I should multiply the 40 by the 50, which is price times quantity. That gives me my total revenue or my total profit for that of yogo. And if I do the same thing, the per unit profit for choco, fan choco, is 50. And the actual quantity of fan choco, we don't know yet, is a decision variable. That is x2. So if I multiply the 50 by the x2, I will know the total profit coming from that variable or that fan choco. And so this is a profit maximization. Okay, so the z here is representing profit. Okay, the z is actually representing profit. And one needs to understand this because If you don't understand, it doesn't help. So this is profit that you are dealing with. Now, on the basis of this whole thing becomes our objective function. And it is probably one of the most important way of learning to formulate. So you got to learn how to formulate. And let me give you a clue, okay, in learning how to formulate these things. You always have to know that you are going to write a Z variable representing the cost, the revenue, the profit, or any other thing, as like distance or, you know, pandemic or audience or anything. Then on the right hand side should be the decision variable. Each decision variable must have a per unit amount, okay, which is its value. A per unit profit, a per unit revenue, a per unit cost, a per unit person, a per unit, you know, something. And that becomes your objective function. The next step is to learn the skills of writing the constraint. So you need to write a constraint, but before you write a constraint, you always have to bring the symbol subject to, and bring a colon, okay? Because the reason why you got to bring this symbol subject to is that you are maximizing this objective, so there must be some limitations, some constraints, okay, that you got to subject that maximization to. And so the next step will be to write your constraint. So we are going to write all of our constraints here. And the constraint will be dependent on the number of resource requirements if you are dealing with cost, or the number of resources if you are dealing with production of something like what we have here. Okay, so the best way to always learn how to write your constraint is to bring those symbols I wrote. Okay, your left hand side of the constraint must always be usage, the resources that you are going to use. Then there must be a symbol, we call it sign, that we are going to deal with. And then the right hand side must be something we call available. Okay, available. Now, the left hand side here deals with the resources that are going to be used. There is a symbolic, you know, relationship between that. And the right hand side, okay, are the resources that are available. So sometimes we call this left hand side, then your sign, and then the right hand side. Okay, that is what is indicated by that. Let me just go to the next page there. So let's now think about, and I'm going to rewrite the whole scenario again. So we have Z max, we have Z max. Let me push this thing up a little. Okay. Yeah. All right. This is lovely. Okay. So we have Z max equal to 40x1 plus 50x2, subject to, I'm using small letters for that, this constraint. Okay. And so let's go back to our constraint. The left hand side of the constraint here, we will need to know the names of the constraint first. Okay, we need to know the names of the constraint somewhere there. So let's just say we need to know the names of the constraint. So let's go back to what are the items that are going to be used to produce this fine yogo and fine chocolate. What are the items? Who can tell me the first resource? The first resource constraint. Who can tell me the first resource? Steven. And the second? Yes.
The first one is labor time.
Yes. And the second one, I said all of them.
All of them. Oh, okay.
You are thinking about the second one.
Then the raw material, which is the gallons of milk.
Is milk. Is milk.
Milk, yeah.
What
Milk.
what
Okay.
other resource? Stay there, Stephen. I want you to stay there. What other resource could have
Okay.
been added, but it wasn't mentioned here? What other resources that could have been added to produce this yogurt or choco that you think of? Anybody? What other resources? Raise your hand. Yes, Kajitan.
I think you need capital.
Capital is too broad. You have to be very specific. Remember, don't think too far. Remember the industry. You're dealing with Farm Milk Ghana Limited. Kobina, Janet.
I think water.
Water. Okay? Water is.
Yes.
What else? What other resource? Mark.
Preservatives and
You have to be very specific here. Anytime you guys are talking, be very specific. It will help you. Michael.
Yes, Prof. I would say the sachet, the rubber for packaging.
I like the way you guys are thinking. All right, thank you. Thank you. What else? What else? Steven. Steven, what else? Okay, so you can think about things like sugar. All right, we could have had another constraint, say sugar. We could have had another constraint called color. All right, and then somebody was mentioning a particular preservative. Okay, so those are some of the things. Okay, but the key point is I want to make it simple. That's why we've just mentioned two constraints. So let's go back to our formulation, and then under where we were before. Okay, we write the names. It's always nice to write the names first. Okay, and so you write the names, and the names become what? The first one becomes labor, because you are dealing with labor time, and then the second one becomes milk. Okay, and always remember that there are always units of measurement for them. So when we're done at the right hand side, we'll add the units of measurement. Okay, now you know the resource. Now sometimes, and we will look at this later on, that sometimes it's not, the constraints are not only resource constraints, but some of the constraints are mixed constraints. Mixed, they are just mixed. It is not for a particular resource, and we'll discuss that later. So let's look at the symbol first. Okay, or let's look at the right hand side. I normally like students to learn how to write the right hand side. The right hand side always talks about the available resources. So when you go to the storyline, okay, when you go to the storyline, what were the available resources for which one? Who can guess? What was available resources for milk? What was available resources for labor? When we say the available resources, we are talking about those resources that are there for that particular period that had to be used or fully utilized. What were the available resources? Okay, Amana, what was available resources for which one?
The available resources
Amana, come again.
would be milk and the scaled
All right, so I'm talking about what was the amount of the available resources. That's what I was asking. I think her network is gone. Yeah, Kajitan.
the available resources.
Yes, Kajitan.
Yeah, I think the available resources will be the 40 hours of labor and the 120 gallons of milk.
Good. 40 hours of labor and 120 gallons of milk. And that is what you want to put on the right hand side. So on the right hand side, you write 40. Okay. And remember the unit of measurement and just bring it. Okay. 40 gallons. Oh, sorry, 40 hours. All right. 40 hours of labor. And so you do 40 hours and then 120 gallons. 120 gallons. So that is what is available. Please note, what is available is different from what is being used. What is available is different from what is being used. And I want you to pay attention here. Okay. Now, this left-hand side is what is used. Now, the symbol will come from the knowledge of whether all that is used are the same as what is available. So I want to ask you some questions to guide you. Can all that are available be used? All that are available, can they all be used? All that are available, can they all be used? Who can tell me? All that are available, can they all be used? Can they all be used? All that is available, can all of that be used? Yes, Apia.
No, sir.
That's what she says. Thank you. Kajitan, what do you say?
I think they can all be used
Yes, they can. Why do you say so?
because those are the limited ones available. So those are the ones available to be used.
Exactly. So let me give you an example. It is available to be what? Kajitan.
Used. It's available to be used, sir.
Exactly. It's available to be used. So if it's available to be used, I gotta use all of it. So all the 40 hours that are available can be used. And if they can be used, if all can be used, then the symbol will be what symbol? If they can, if all of it can be used, then the symbol is what symbol? Kajitan. The symbol between the left-hand side for labor and the right-hand side for labor will be what? Morrison. What symbol will indicate that all of them can be used? If I can use all of them, then the symbol is what? Is equal to. The symbol is equal to. So I can use an equal to indicate that all the labor hours, okay, that are available on the right hand side can be used. But the question we need to also ask ourselves is that, is it possible that you can have the resources available and you wouldn't use it? Is it possible? Is it possible? You can type it in there. Is it possible that you can have all the resources available and yet you would not use it? Is that possible? Who has an idea? That you can have all the resources available and yet you will not use it. Is that possible? Yes, it is. Exactly. It is. Why? Okay. Why are we saying that it is possible? Because we see that happening. A lot of people have 8 hours to work in a day. They go to the office, they get to the office, they start reading the newspapers. By the time they realize 1 hour is gone, they start talking, chit-chatting, okay, WhatsApping, social media, and by the time they realize 2 hours is already gone, it's already lunchtime, the available hours for the day, 8 hours, has not been used. And when it is 5 o'clock, they are the first people to speed off from the office. And so there is a lot of dead weight loss to society. There's a lot of resources that are not used. So it is possible that the usage here will be less than the available. And so that makes it what? Less than. Okay? That makes it a less than situation. And once you have a less than situation, okay, then we can say that the symbol in question is less or equal to. So the symbol for labor will be less or equal to. And ladies and gentlemen, believe in me, the symbol for gallons of milk, as long as a resource is a resource, the possibility, anytime you have a maximization like this, the possibility of resources being fully utilized or somehow not utilized is less than or equal to. And so this one will also be less than or equal to for the gallons, as long as they are resources used for maximization. Now we are left with the left-hand side of the equation, and then we are done. The left-hand side. And the storyline will give you an idea of the left-hand side of the equation, that will help you to formulate the model. So let's go back to the storyline. In fact, the information given there guides us into writing the model. And you get that information here in the second section. It says fine yogo requires 1 hour of labor. Now be careful and follow the line. Fine yogo is X1. 1 hour of labor is under labor column. And then it says fine choco, which is X2, also requires 2 hours. So 1 hour for yogo, 2 hours for choco. 1 hour for yogo, 2 hours for choco. Let's go to our analysis. Okay, 1 hour for yogo. So where is yogo line? Well, if you look at this line, it should follow the same line. Okay, just that I have not written it, because when you write it in follow. So if you look at the yogo line, this is it. This yellow, 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 yellow. Okay, that's yogo line. Choco line is this section. Okay, so I want this section there to be yogo. Okay, so this is a yogo section there, and this is a choco section there. And because yogo is X1 and choco is X2, these numbers must carry the value. So under the labor, you did one. Okay, let me use my symbol. You need one. You need one. One of the labor time. So to produce choco, so I call it 1x1, because to produce yogo, so that makes it 1x1. And then I add the 2 hours for the production of choco, so that will be 2x2. So you have 1x1 plus 2x2. These are the usage. These are the number of hours that are used. Number of hours that are used, okay, in the total production of both yogo and choco, of both X1 and X2. That's why I'm adding them, of both X1 and X2. And when it comes to the milk, that information was also given. So who can tell us how to formulate the milk constraint? The milk constraint. Let's go to the storyline. Who can tell us how to formulate the milk constraint? Mathematical formulation is just following a pattern. Okay, who can tell us how to formulate the milk constraint using the storyline here? Because we've already formulated the labor constraint. Yes, Morrison. Give us an idea.
Doc, please. The milk constraint will be 4x1 plus 3x2.
Good. Okay. So let's go back here. If you look at the storyline, it says yogo requires 4 gallons and choco requires 3 gallons. So again, it's 4x1 for yogo, 3x2 for that. And that's it. Okay. So with that packaging, you now go to this section, all right, and then you go and write it exactly as it's supposed to be. Okay, so that becomes 4x1 plus 3x2. Okay, 4x1 plus 3x2. Now let me go to, so sometimes when you've done this rough exercise, you now go to your actual formulation, which we started from here. Okay, and you can now beautify them and say that subject to, okay, for labor, you have x1 instead of instead of 1x1, you now have 4x1. Instead of 1x1, you just have x1. All right. Okay. So you just have x1. So you write x1 plus 2x2 less or equal to 40, and then 4x1 plus 3x2 less or equal to 120. You can add the units of measurement, you know, for hours here and then for gallons there. Now, once you are done with this, and these are the only constraints that we have, these are the only resource constraints that we have. There's no mix constraint, and so we can go to our final constraint. It's never mentioned, but it must always be attached. And that constraint is known as the non-negativity constraint. The non-negativity constraint. Now, the non-negativity constraint is a very powerful constraint. It simply means that the decision variables, the x's, the x1s and the x2. Okay. So here I forgot to add the 2. Forgot to add the 2. Let me just delete them. Okay. Forgot to add x2. So the x1s and the x2, if you look at them here, okay, there must be a limitation on them, and that is called a non-negativity constraint. So let's go back there. The non-negativity constraint says that each of these x's must be non-negative. In other words, they must be 0 or positive. Okay, each of the decision variables have to be 0 or positive. So x1, okay, x1 comma x2, okay, should be greater or equal to 0. That is it. That is it. That is it. And that is a non-negativity constraint. So what you've done is that you have been able to convert this entire storyline. Let me just show you this entire story of information into, which is very difficult to try and solve, because the goal is this. The goal here, where is the goal? The goal is to formulate, all right, formulate a linear programming model to solve it graphically. And formulating it is the most important thing, because if you can't formulate it well, you cannot solve it graphically. And what we have just done is to learn how to formulate it beautifully. Stephen, is your hand up, or you are supposed to lower your hand? All right. Now, at this stage, any question? Let me just show you all that we've done, because I'm going to ask you some questions. So I put everything into a table like this. And then all that I've done with you, I've gone through it with you, are all in the slides here. The decision variables were mentioned. The formulation of the objective function, which is a z function, is there. The resource constraints are here. Now let me ask some few questions from this. How many resources were available? Based on the story, and now that we've done the formulation, I need some quick answers for this. How many? I think some people were, I think you can now unmute yourself. How many resources were available? Stephen. Yes, Stephen.
Please, we had 2 resources.
Okay. Are they limited? Stephen.
We had 2 resources, please.
Are they limited?
They are not limited. They are not limited, please.
Stephen, they are limited.
They are available for usage.
They are limited, Stephen.
Oh, less than.
Yeah, you aren't following that. They are limited. That is why we have to write a constraint for them. So they are limited. Okay. Let's go to the next question. Okay. How many hours of labor and how many gallons of milk do you need to produce fine yogurt? How many hours of labor? Let's talk about labor. Okay, remember the formulation. Okay, I just hope that you were doing the formulation when I was doing it as well. Okay, this is the formulation. How many hours of labor are used to produce fine yogurt? Looking at this formulation, let's see. Michael, how many?
40 hours of labor.
No, that is not correct. Okay.
40.
Don't worry. Once you get it wrong, don't worry. Don't change the answer. Let's move on to the next one. Okay, next person. Because you must think about it first. It's not lottery. Think about it a little bit and then you can get it. How many hours of labor? They are all here. Kajitan.
You need 1 hour of labor to produce fine yogurt.
Thank you. How many hours of labor are needed to produce fine choco? Mark.
Hello, you need 2 hours of labor.
Good. Now, once you are done, just mute yourself because I'm going to be asking some plenty questions. How many gallons of milk are needed to produce choco? Appear. How many gallons of milk are needed to produce choco? Okay. I think your network isn't good. Okay. Your network, you can just type in there, section there. You can just type it. Okay. How many gallons of milk are needed to produce choco?
4 gallons of milk, please.
All right. Okay. That is wrong because I was asking how many gallons of milk are needed to produce chocolate. It's not 4 gallons. Okay. Eunice. Eunice is 3. It's 3.
Please, you need 3.
Yeah, you need 3. Because I was talking about this variable. Okay. This variable. That's what I was talking about. And not the 4. Now let me ask further question. Let me ask further question. What is the total number of hours used by Farm Milk Ghana Limited? What is the total number of hours used? Somebody is interrupting us. What is the total number of hours used? What is the total number of hours used? Mute yourself, Eunice. What is the total number of hours used? Stephen.
Please, it's 40 hours.
No. What is the total number of hours used by this company? Amana. Amana, what is the total number of hours used?
The total number of hours used would be 40 plus.
Go ahead, we are listening.
40 plus.
Okay.
That makes it.
We lost her. You can type it in the chat there, but I don't think you're correct though. Janet, what do you say? Janet.
Total numbers of hours used is 3 hours.
That's wrong. Okay. What is the total number of hours used in this company? Morrison, mute yourself.
Doc, can I come again?
Morrison, mute yourself. What is the total number of hours used in this company? Michael. Michael.
Doc, I'll say 5. That's 4 plus 1.
That's wrong. What is the total number of hours used in this company? Janet. Janet. Janet.
I would say 2 hours.
Okay, that's wrong. What is the total number of hours used in this company? This is interesting. This is really, really interesting. Okay. Total number of hours used in this by this company. That is becoming difficult for you. Let's go to Steven.
Doc, can I come again, please?
Yes, but you can come again by raising your hand. You don't need to,
Doc,
you don't need to
okay.
unmute yourself, okay?
Yeah,
We are
alright.
doing a very professional communication, okay?
Okay.
All right, go ahead.
All right. Doc, it's a maximum of 40 hours.
No, that is wrong. Okay, Amanda, you didn't type your own because your network is bad. Unmute yourself and answer it again. Let me see. What is the total number of hours used in this company?
The total number of hours used would be the total as the 50.
Amana, your network is really bad. Can you type what you just said? Just type the amount, the number, the mathematical formula, anything. Type it in the chat there for us to see. Okay. Total number of hours. I want her to do that last because if there's anybody who came close, it's her. If she cannot get it, then I need to give you the answer. The total number of hours used in this company. Okay.
Sir, please, I've sent it.
The total number of hours used, 40 plus 50. All right, so that's the. All right, so let me just share with you guys why you are all wrong. The total number of hours used, and I'm going to just identify, circle them here for you guys. This is the total number of hours used. Oops. Okay. This is the total number of hours used. Okay. That is x1 plus 2x2. That's the total number of hours used. That's the total number of hours used. Okay. Here, x1 plus 2x2. It is the left-hand side of the entire equation. That is it. Because remember, this left-hand side of the entire equation was representing labor. Okay. So labor, let me just go to the next page. Okay. So you have Z max, okay, equal to 40 x1 plus 50 x2, subject to the following constraint. And you have x1 plus 2, x1 plus 2x2, less or equal to 40. And then you have 4x1 plus 3x2, less or equal to 120. Then you have your non-negativity constraint, x1, x2, okay, greater or equal to 0. Now, the left-hand side here, okay, this is the left-hand side, this is a sign, and this is the right-hand side. The left-hand side here is the total hours. So this is for labor. That's the total hours. And this total hours is the total number of hours used. Remember, I told you that the 40 hours is available, but you don't know how many of the 40 hours was used. You don't know. You don't know until you have estimated the actual values of x1 and x2. Until you found the actual values of x1 and x2 and substituted them for this left-hand side. Until you do that, until you do this, you will not know the total number of hours used. So the total number of hours include the 1 hour used to produce fine yogo, which is this first part, and then the 2 hours used to produce a single choco. So the 2 hours is for producing a single choco, and the 2x2 is the hours used to produce the total choco. The hours used to produce the total choco is a 2x2. And the hours used to produce the total yogo is the 1x1. And so the total hours used in this company is the x1 plus the 2x2. I hope you get it now. Now let's go to my next question. What is the total hours, what is the total gallons of milk used in this company? What is the total gallons of milk used in this company? What is the total gallons of milk used in this company? Yes, Kajitan. Let me see, I think. Yes, Kajitan, try and unmute yourself now.
Yeah.
Mm-hmm.
It's 4x1 plus 3x2.
Good. Catch it and stay there. Now, what is the total gallons of milk?
Yeah.
What is the total gallons of milk used to produce choco? Used to produce the whole of choco. The total.
4 gallons of milk used to produce sugar.
Sorry?
I think it's 3x2. 3x2.
Correct. Correct. Stay there. What is the total gallons of milk used to produce fine yogo?
4x1.
4x1. Good. Now listen carefully. And this is tricky. What is the total hours used to produce fine yogo and the total gallons used to produce fine choco? What is the total hours used to produce fine yogo and the total choco? Sorry, and the total gallons of milk used to produce fine choco? Janet. Janet.
So the total hours will be 1x1,
Yeah,
3x2.
exactly. So you have 1x1 and then 3x2. I hope you didn't add them. You cannot add them because they are different things. We are talking
Variable.
and gallons. So I hope you did not add them. So it is 1x1 and then 3x2. So you must master. Every one of you will have to master the way you understand the formulation. It's not just a mathematical formulation that you've just made, but you have a mathematical formulation and yet you have also understood how the formulation is made. So most of these questions are here. Now let me find out from you, what is the total labor used by the company? What is the total labor used? Look at this last one. Total labor used by the company, by the Farmer Ghana Limited. Okay. Total labor used. Who can tell me? Total labor used by the company. Again, we've done it already. What is the total labor used by the company? Anybody? Yes, Kajitan. Kajitan. The total labor used.
1x1 plus 2x2.
Exactly. That is the total labor used. Okay. So that is how you got to understand. So formulating it is great. Understanding what you formulated is even better. Okay. Janet, your hand is up.
Yeah, please, does that mean that the total labor used is equal to the total number of hours used?
Yes, it's going to be the total number of hours that have been used. But of course, right now, you don't know the actual number because you don't know the value of x1 and x2. So you have to answer them as a kind of an equation until you have the actual values, which you will have. We will solve it, and then you substitute it, and then you know the actual numerical value. You understand? You get it? All right. Now let's go to the slides. And so based on this slide, this is what we did. Okay, if you read the slides, you will understand everything. The non-negativity restrictions. This is it. Our job, which we are going to do next time, is to learn how to now find the values of the decision variables. These are questions 1, 2, 3, 4. We are going to solve this equation. We will solve them graphically. We will also solve them using the simplex method, the one I told you about, which is the algebra. And then we'll solve them using a computer so that you master how to do that. Once you've been able to do that, there is no way linear programming can beat you. The only next thing is when I increase the constraint by more. These constraints are just 2. Or the next time when I increase the variables by x1, x2, x3, x4, add more variables to it, add more constraint to it. But it doesn't matter. The principle is the same. Once you're able to master how to do it like this, you will be able to master any linear programming approach. Okay, so next time we'll look at the formulation. Ladies and gentlemen, that brings us to the end of the entire caboodle for today. Any question?